Have you ever just stopped and wondered how we actually speak? I mean, we do it all day, every day without a second thought. But behind this simple act, there's this whole hidden world of science. So welcome. In this explainer, we're going to pull back the curtain on phonetics, the blueprint that dictates every single sound we make and understand.
Just take a look at these words for a second. Rhythm, laugh, enough. They're all so different, aren't they? The spellings are all over the place. You've got silent letters, weird combinations, and yet we just know how to pronounce them. It really makes you wonder, right?
And that's the big question, isn't it? Why on earth is English spelling so confusing? The letters we see on a page just don't seem to line up with the sounds we actually make. But what if I told you there's a system, a kind of secret code that cuts right through all this confusion? Well, that system is phonetics.
So let's dive right into this science of sound. The best way to think about phonetics is like a blueprint for language. It's the set of rules that brings order to the beautiful mess of spoken words, explaining exactly how we produce and hear every single sound.
So what is phonetics, really? Well, simply put, it's the scientific study of speech sounds. It looks at the whole journey of a sound, right from the moment it's formed in our mouth, to how it travels through the air as a wave, and finally, how it gets picked up and understood by someone's brain. It's the A to Z of a sound.
And this whole field, it breaks down neatly into three main branches. First up, you've got articulatory phonetics. That's all about how we physically make the sounds. Then there's acoustic phonetics, which looks at the sound waves themselves. And finally, there's auditory phonetics, which is all about how our brain makes sense of it all. Put them together, and you've got the complete story of speech.
Okay, so let's zoom in on that very first branch, the articulatory side of things. I want you to think of your own body as this incredibly advanced, personal sound machine. Seriously, each one of us has this amazing bit of kit, and it can produce this huge variety of sounds.
It's actually amazing when you see how many different parts have to work together perfectly. Look at this diagram. It all starts with air coming up from the lungs, passing through the larynx, which is our voice box. And then it's shaped by our tongue, our lips, our teeth. Every single part has a very specific job to do. And this diagram here, it shows the key places of articulation. You know, a good way to think about these is like the frets on a guitar. They're the exact spots where we block or squeeze the air to create different notes, or in our case, different sounds. It's an incredibly fine-tuned instrument.
Now, here's a really important idea to get your head around: active versus passive articulators. It's simple, really. The active articulator is just the part that moves. Think your tongue or your bottom lip. The passive one is the stationary target it moves towards, like your top teeth or the roof of your mouth. And that simple dance between the two, that's what creates almost every sound we make.
So, if spelling is so unreliable, how do we actually write sounds down in a way that makes sense? Well, for that, we use a special decoder key called the phonemic script, and it's built using symbols from something called the International Phonetic Alphabet, or IPA for short.
And this is our decoder key. It's the phonemic chart. You can honestly think of it as the periodic table of sounds for the English language. And the most important rule is this: each symbol stands for one and only one sound. No confusion, no exceptions. It's a universal map for pronunciation.
Let's see how it works. Take the word cat. It's got 3 letters. And yep, 3 sounds. K, at. Simple enough. But now look at shoe. 4 letters, right? But it only has 2 sounds. Shoe. See? This script shows you the real sound of the word, completely ignoring the messy spelling.
Okay, so we've got our code. Now let's get into the building blocks themselves. What are the actual fundamental sounds that make up every single word we speak in English?
Believe it or not, the entire vast English language is built from just 44 distinct sounds. These are called phonemes. That's it, just 44. Think about that for a second. Every single word, from the most complex scientific paper to a simple text message, is just a different combination of these 44 sounds.
And these 44 sounds fall into 2 main groups. First, you have the vowels. This is when the air flows freely right out of your lungs, like the E sound in C. Then you have the consonants. This is where the airflow gets blocked or squeezed in some way. Think about that hard stop for the P in pat, or that buzzing friction for the Z in zip.
Now, this is all fascinating stuff, but you might be thinking, okay, so what? Why does this actually matter in the real world? Well, it turns out this isn't just theory. Phonetics is an incredibly powerful and practical toolkit, especially in the world of technology.
Because here's the bottom line. Phonetics is the absolute foundation of modern voice technology. Just think about it for a moment. From your Alexa or Google Home to the smartphone in your pocket, if you want to teach a machine to understand a human being, you first have to understand the basic ingredients of our speech. It's absolutely crucial for AI, for designing better user interfaces. It is, quite literally, the science behind Siri.
All right, time for a little test. On the screen right now is a paragraph written completely in phonetic script. What I want you to do is pause this explainer for a moment and see if you can decode it. Go on, give it a shot. You're not just reading letters anymore, you're actually reading sound.
And there you have it. That's our journey into the science of speech. We started with some really confusing spellings and ended up with the precise code for sound itself. We've seen that speech isn't some kind of magic. It's a physical, mechanical, and totally understandable process. So I'll just leave you with this one question to think about. Now that you can actually see sound, what are you going to listen for?